So today we have Steve Hoyt, principal at Hastings, and he's going to talk to us about window performance and window films. Not an unsophisticated topic at times, but I also like to, since we have them here, just mention their really exemplary performance and outreach to our industry. Not only spending time here today, but coming or just past the sponsors of the Just Big Enough Greenhousing for All design competition that we had up in the exhibit space for a couple of weeks. We've got coming up Women in Architecture lecture, conversation with Frances Halsman. So you've all seen stuff on that coming through on emails. So we're really glad to have him here, and welcome, Steve.
All right. Thank you very much for the introduction. It's great to be here. My name is Steve Hoyt. The company I work for is called AW Hastings. And as Carl referenced, we've been doing this for a long time, going back to 1846. I did not work there at that time. I've been around a little bit, but not that long. So the company has been involved with windows and doors going way back to the 1800s. It's pretty amazing. Pre-Civil War era. At one point, our company would ship windows on clipper ships all the way around Cape Horn, South America, all the way around to San Francisco, going way, way back. So there's a history with our company with windows and doors that goes back and can predate. So there's a lot of cool stories that we have. We found our product all over the country because it used to be shipped via railroad and trucking. Right around the early 80s, we got out of the manufacturing side of the business and we got into more distribution. So what does that mean? In turn, instead of us producing the actual windows as a company, AW Hastings became the sole distributor for a brand called Marvin Windows and Doors. So if you ever look at these little window walls here, this is an integrity window that is a fiberglass window that's made by Marvin. Marvin also has an aluminum clad and all wooden product that they sell as well. So we transitioned into more of a distributor, but with that, right at that time, there was a huge boom in technology. Things shifted. If you've ever been into an older home, what do you notice about the windows? You go up to the windows, they're older. How many panes of glass do you see? Just one. Just one, right? So what happens if one of those breaks? You have to reglaze it, right? As individual panes of glass. So that was really the traditional way a wood window was made. It was single glazing and it was clear. The glass was clear. So the evolution of glass, the creation of glass was in its own right, from a technological standpoint, was a huge development. The next big step in that was moving to a point where glass and glazing became a high performance feature of a window, which it wasn't always. So I think it protected initially from the outer elements, so rain, wind, things like that, which was a huge technological advancement. The next big boom in glass was kind of in the late 70s. They went from single pane glazing into, everyone take a guess, double glaze, right? And so basically that was like mind blown, right? What are we going to do next after this? The evolution after that came, they developed technology where they would put what's called glazing. And it sounds a lot, it makes me hungry whenever I say glazing. But, glazing literally is a coating, like a glazed donut, right? Coating on the glass that increases the overall performance of the product. We'll talk about it in a little bit more detail, but just simply put, to go from a single pane of glass to a dual pane of glass, increased performance, right? And then by putting these coatings on glass, it is further enhanced. Taking it a step further, most recently, the last 10 or 15 years, there's now something called triple glazing, which is 3 panes of glass with coating. So as you can tell, we started in the early history of Windows, single pane with a clear pane of glass that had okay performance, to now we're getting performances that are almost equal to an insulated wall cavity, which is pretty impressive. Because of this, what we're seeing in architecture and design If you take a look at buildings now, when you look at buildings from, say, the energy crisis in the 70s, there's a couple of them on campus here, right? What do we notice about the windows on some of these concrete buildings? Small. Why? Well, what is it about windows that make them less likely to perform? Yeah, right. So a wall, right? You're basically punching a hole in a wall, which is one of the most thermally efficient things, parts of a building, and you're punching a hole in a wall, okay? Drastically reducing the ability for it to perform. You put a piece of glass in there, right? That's going to further reduce the ability of the building to perform long term. So back in the day, there was a little concern about how much of an opening do we create, because that makes a window less, or makes a building less efficient. Nowadays, what are we seeing? Like this building is a great example. All glass, right? So the reason we're able to do buildings like this is because window technology has evolved to the point where you can do large, mass scale, large pieces of glass, and you can get high performance. So it's kind of it's a fun time. It's a fun time to be in the window industry because people want to build these large spaces with tons of glass, and being in the window business, that's a good thing, right? So I think it's an exciting time from an architectural standpoint. We're seeing a resurgence with contemporary architecture. We're seeing homes that are, traditional in the front and sort of just large expanses of glass in the back. And the reason this is possible is because the building envelope has been optimized, right? And then also the glazing and the glass that are in windows has been optimized. Therefore, we're in a much better space as it relates to putting a window into an opening. So how many of you have taken a look at these samples before? Like, quick show of hands.
These are hot off the press.
They're hot off the press?
So
all right.
They haven't been, I think they're literally 24 hours from completion.
Oh, wow.
So
Okay.
You were really the deadline.
Okay. All right. Stop slacking. Take a look at these things, right? So these are, this is our product that we donated here, but I think this is just an awesome example of wall detail, right? Showing two different methods of construction that optimize performance. This is the outie window, correct? And that's the innie. What you're seeing is some insulated board here. What are the R ratings on these walls?
So we only, if they were, we don't have any cavity insulation in here, right? We're interested in showing the other side.
Yep.
So if those were 2x6, probably running low 30s.
Okay, great. So this is new technology, right? And it's an example of, when you come take a look at it, how building has sort of progressed and how efficient things are now. And to go with that, we'll talk a little bit about the glass and the windows that are going into these openings now, and how those are basically the highest performing products that you've seen probably in the history of windows. It's not necessarily just our brand, although I am partial. There are a lot of window brands out there that perform, but I think what we're seeing nowadays is the technology plus with building technology, which is a great time period in construction, where we can build high performance homes without losing a lot of aesthetics, which traditionally, in order to build a high performance, sometimes it just had to be very thick walls, very block looking construction. So it's a very, very interesting time. So the topic today, performance glazing and building envelope optimization. This is part of an AIA presentation that we put together, and we typically give these presentations to architects. We have a few architects in the room today. And how many aspiring architects do we have? Excellent. So these are part of our Lunch and Learn series, which is great. We buy you lunch and you get to listen to fun stuff about windows. So this is a presentation that we typically do. And so what we're going to talk about is performance glazing and building envelope optimization. A couple things we're going to talk about are things called low-E coatings. And low-E stands for low emissivity, and we'll describe what that means, how it works from a scientific and an application standpoint. We'll talk a little bit about the manufacturing process, and we'll show the benefits of low E and how that relates to energy efficiency. So the way we're going to do this, we're going to talk a little bit about how do we rate windows. So I was asking Carl kind of what's the rating of that wall thickness. In the window world, every single piece, every window that goes into an opening is rated. So what that means is there's an independent council that rates and tests the performance of all products. Everything that goes into a building is tested. And you're probably learning this right now. Shingles, right? Plumbing, electrical, all of this. It's all rated. There's typically an industry group that is testing, strength, durability. We have the same thing in the window world. And that's the NFRC, or the National Fenestration Ratings Council. So we'll understand what the NFRC is and how we can test and rate windows. We can understand the science of the light spectrum. So this is what I think is pretty interesting, is different types of light affect the performance of a home. So whether it's UV light or infrared light, and we'll go into the light spectrum. We'll discuss different coatings and glazings. We'll describe how they're applied. And then we'll talk a little bit about how to optimize and engineer a building to essentially gather heat. So we're in a northern climate here. We want to, especially in this extended winter we're having, we like absorption of solar heat, right? So typically in the winter, the more heat that you absorb in a home, what does that reduce? The need to do what? Heat your home, right? So by using different types of glass and glazing, you can have on the south side of your home, you can have a certain type of glass that absorbs heat, right? So your room, let's say it maintains a 72 degree temperature during the middle of the winter without even turning on your furnace, right? That's when we start to get into what's called more of a passive house or a net zero. Because what you're doing there at that point is you're able to operate your home by using correct glazings and the correct type of window product. You can actually operate your home without using any sort of heating and cooling method. And that's kind of the future, and that's kind of the direction where a lot of building is going right now. Net zero and passive housing. So we'll talk about how to optimize your designs in order to do that. So right off the bat, I'm not sure, is this rolling here? Right off the bat, when you get any window from a North American produced window, you're going to see this sticker right here. This is what's called the NFRC label. This is just kind of a generic version. And basically what you're going to see on any NFRC label are criteria. And the criteria are U factor, solar heat gain coefficient, visible transmittance, air leakage, and then condensation resistance. So typically when we're building and we're putting together a project, let's say it's a commercial project for, I think South College was probably the largest project we've done on campus here. Everyone familiar with South College? So on the front part, the historic part, that's all Marvin product. So when we put that in, there was a certain U factor that we were required to hit. So basically what you can do on any window, if you're quoting or specifying it, is you can pull data from that manufacturer's website that'll have the information that's required. So an architect may specify that a U factor must be a 0.30 or less. Okay? So in this case here, this is a vinyl window, wood frame window with a U factor of 0.35. Does everyone see that upper left? So that means that this window, that type of window, would not be a high enough quality window to be used on that project. Does that make sense? So it's basically like a certain threshold. The reason the NFRC came into creation is, we'll go back to the 70s. A lot of people made a lot of claims about the performance of their product. Anyone here drive a Volkswagen? Anyone have a Volkswagen diesel? All right, is everyone familiar with the Volkswagen and what happened with Volkswagen? So, they were making high performance cars, but then there was also, I don't know, how would you call it, an embellishment as to the level of performance of the car. cheating, is that what you're saying? So it's still a great car, but I think what they started buying back the cars because they were kind of misrepresented. So essentially what has happened, what's happening in the window industry is the same thing. So a window company would come out and say, hey, this thing performs at a 0.21 U factor. Non-tested, non-rated, there's no certification body, so people believed them. And so they would put the window in and it wouldn't perform to the levels or the criteria that was specified. So essentially what happened is all the window companies got together and said, this is kind of killing our industry. We're losing credibility. So we need to come up with sort of a set ratings standard. And that was what the NFRC is creating. So, question?
Is this only applied to residential windows, or is this, like these units in this building right here, is the same?
Yeah, they also do commercial as well. So there's a higher level commercial like skyscrapers and stuff like that. But these here are commercial windows, but I think they would fall under the same NFRC ratings. So it's kind of a mix.
So these might or should come with those same stickers?
Typically, yes. Yep. So other things that are on here are solar heat gain. So solar heat gain coefficient is just essentially solar heat gain. So how much solar heat is obtained by a window, right, and retained by a window. So the higher the number of the solar heat gain, the more heat that is brought into a building. Okay, so typically, if you live in a southern climate, okay, let's say you live down south, how important is solar heat gain? What are you trying to do with the heat? Pushing it out, right? So essentially what you don't want is a high solar heat gain. So what you'll see down south, you see a lot of tinted windows. You see a lot of shading, because what they don't want is they don't want to absorb, because what does that do? It increases their cooling costs, right? Energy costs go up, etc. So that's what the solar heat gain. Visible transmittance, essentially what that will tell you is how much light is actually coming through a window. Air leakage relates to the overall seal of a window. So initially, when you get a number, it can be center of glass. What that means is, on that piece of glass right there, center of glass housing or form. One of the things is, a lot of manufacturers, before NFRC was created, would use center of glass ratings. But the second you put that glass into a frame, right, you have to seal the frame, you have to use adhesives, you have to put the window. The window is basically, it's a compiled and manufactured unit. So that number, 0.35, relates to the whole window performance, not simply center of glass. And then condensation resistance. Now, this is an interesting one. It's become more common. Has anyone ever seen condensation on a window? All right, how does it occur? So basically, you wake up one day and the inside of your window is sweating, essentially, right? It's humid inside the home and it's cold outside. And there's typically seasonally, at Hastings, we call it basically the fall is when we get a lot of condensation calls. Because the house has been warm through, heating up over the summer and into the fall, and then the temperature starts to drop outside, right? So you get colder nights and warmer days. And essentially what happens is the window starts to condensate. So we'll get phone calls saying, what's going on with our windows? And we say, well, what's the indoor temperature of your home? What's the humidity level? We've gone on some service calls, as we occasionally do, and people will have their heat cranked to 80 degrees and we'll have plants all over the house, and it's basically like a tropical environment on the inside, and it's 38 degrees on the outside, and they're wondering why they have condensation. All right? So there's so much humidity inside and heat inside a home, but it's cold outside. In the Northeast, this is an important rate, condensation rate. So on all windows, you're going to see some type of NFRC label, and there's data and then there's information. Not to go too deep, but a lot of the work I'm doing right now with architects is related to the performance of a product. So when we talk about our product specifically, whether it be Marvin and Integrity or Infinity, we're talking a lot about aesthetics and options and what can you do with the window. But now on the architectural side and the design Because not only do people want a building to look good, but they also want it to perform. Question?
Quick question with this, because whenever I see a single number, I'm always curious whether that's the low bound of a certain range, and if there's what kind of factors you see there. Like, for example, air leakage. Over the production run over many years, is this much?
Does it decrease?
No, I'm just curious if this is most probably a low bound to some kind of variability.
Right.
Is there much variability in any of these numbers, or like visible to visibility? It probably depends on where you guys get your glass from and so on. So is there much variation over the years?
I think typically where you'll see some variation is with U. So I guess I should have been a little bit more clear. The lower the U factor, the better performing it is. So what you typically want is a low U value. Solar heat gain is the same. If you want lower solar heat gain, you want a lower number. Higher solar heat gain means you're going to absorb more heat into the home. The U factor, because of glazings and because of they actually pump gas in, like argon and krypton gas, into the insulated cavity. So if you look at just, this is just a corner sample, corner cut of a window. If typically when this is all sealed, there'll be a clear, non-visible gas that is pumped into here. And that also allows for better performance. However, what happens over time is they call it a dissipation rate. And so essentially what happens is the gas sort of breaks down a little bit. But typically everything is air sealed. So you're not getting a high dissipation rate because it'll take 50 years before the argon gas begins to dissipate. So you'll see a little bit of variability over time. This is kind of out of the box. I can tell you this: the better and more well-made the product is, the more the consistency you're going to have long term. That gets into the whole other. We have a whole other topic.
Was, if you bought 10 windows, what's the range? Would it be all exactly 45 wood, or they work the 6? Yeah.
They should be pretty darn consistent. Yeah. All right. So we talked a little bit about this. NFRC ratings are derived from the component. So the glazing component, which is the glass. Okay. The frame component, which is what the unit is built out. So basically, you have a couple of different things here. So these particular units here are fiberglass, right? The full-screen fiberglass with a glass system. Okay. So then in each window, you're going to have your glass, you're going to have your frame system, and then you have your spacer. And so the spacer, or what's called the spacer bar, is actually what's in between the glass. It's aluminum or stainless steel. So the type of material that they use in between the glass actually can create a lot of variability in performance. So stainless steel has less thermal transference, and then they also put what's called a desiccant inside the spacer bar, which reduces the amount of thermal transfer from one pane of glass to the other. And that can affect the overall performance. So it doesn't look like much, but if you want to pass this around, basically this spacer bar right here is a critical piece in the overall performance of a window if you want to pass it around. So today what we're really going to be focusing on is not necessarily the spacer, not necessarily the frame, but we're just going to be talking about the glass, the glazing and the infill and the center of glass assembly. So the solar light spectrum, this is just a picture, this is a rainbow after a rainstorm. But what you're seeing is different types of light in the spectrum of light. Okay, and you're seeing different colors. Now these different colors actually mean something. And what you're seeing with those purple and violet on this end is what's called UV rays. Everyone familiar with the term UV? Okay, what is UV? What does UV rays do? What does it break down? Creates a lot. Has anyone ever been in a home and you see you put a nice new rug down, and then 6 months later you go back over to the rug and it's all faded, right? So UV light, which is invisible, and it's the violet part of the rainbow, okay? UV light goes through an opening, and it can fade the entire interior of a home. So it becomes invisible. So you're not perceiving that what's happening, but that's what's happening. Light's coming through, and it's slowly fading the interior, what you have inside. That visible light is kind of the greens and yellows there, and then the infrared is the invisible. So the UV is where the fading occurs. The infrared is where a lot of the heat comes from. And that's sort of all what's in the spectrum. So visible light does not actually take up, that's kind of what we're talking about, that 0.51 of visibility. But what we find out with glazings is that it helps protect you from UV and then also the infrared light, the light that you don't see. So how does this happen? So this is a typical diagram of the sun. And essentially what happens is the sun and heat is sent towards the window. And what happens just on a typical dual pane window is the window will either reflect or absorb light, and it'll transmit ultraviolet light, visible light, and heat. So this is all happening. So sun, reflection, everything kind of comes towards a window, and it's either going to do one of multiple things. It's either going to reflect and bounce the light away. It's either going to absorb it, and it's going to transmit UV light, visible light, and heat. So there's a lot going on with the window as it relates to heat. So what do low-E coatings do? Low-E coatings help deal with the energy that's coming towards the window. It can produce energy savings. There is something called, in Massachusetts, there's something called stretch code. So certain towns have specific codes that are required. So if you're going to build a home, there's things like egress, okay, escapability of a bedroom. A window needs to be opened a certain amount for it to be escapable. There's codes related to electricity. There's codes related to energy. And there's also now codes related to performance of windows. And that's something that we see in the stretch code. And I believe Amherst has a stretch code. And so basically, if you're going to produce and build a home, let's say it's a residential home, you may be required, according to the stretch code, to meet a certain U value. And if they walk in, code inspector comes in, and they look at the sticker, you got to leave the sticker on, and that number does not equal what the code is, they're going to make you take it out. It's not going to meet code. So it's now becoming a part of everyday conversation on a job site. These numbers. Other reasons for low-E coating: thermal comfort. So the overall comfort of a home. Has anyone ever been in a freezing cold house and you wonder why? Right? And a lot of it has to do with the windows and insulation. To be inside of a home, even on a hot summer day that's not using air conditioning, if you have the right low-E coatings and maybe a triple pane of glazing, your house may seem a lot cooler because it's reflecting all the heat out of the home. So low-E coatings work both in winter and in summer. Reduction of fading. If you're a rug collector or have, oriental rugs or anything like that, total reduction of fading. Daylight control. I'll tell a funny story. We went to this beautiful house on top of a mountain facing south. And they had this awesome great room. And there's just glass, probably like this tall, just glass everywhere. And they had kids, and they had a little side room. And all the couches and the beanbag chairs and everything were in this little side room. And we're like, we have this awesome room. Like, why don't you use it? Because I call it way too hot. We can't even sit here when it's sunny. And when they designed it, when they built the home, what they didn't take into account is it was south-facing, and it was all glass. So there weren't any tintings. There wasn't really a lot of daylight control or any shading. So they basically built this beautiful environment, but they couldn't actually sit and use the room because it was too hot. They couldn't control it. So those are the types of things that you want to think about when you're talking about glass and glazing, and then also just the design of a home. Also sound buffering. We run into this a lot, just locally, like whether it's downtown Amherst or Northampton. We can actually put laminated glass or a type of glass that basically reduces the amount of outside travel of noise. And that's sound buffer. So all of low E can help with all of these things. So it's quite an invention. So energy codes, we don't have to dive too deep on this. This is just kind of a surface level. There's a couple of different groups. ASHRAE is the American Society of Heating, Refrigerating, and Air Conditioning Engineers. And there's compliance related to sunlight and electricity trade-offs, building envelope energy, and window-to-wall ratio methods. What that means is, essentially, you gotta be in the right ratio from the amount of windows you have to the amount of wall space that you have from a performance standpoint. So ASHRAE is another group that kind of creates and sets these criteria. The IECC, the International Energy Conservation Code, references ASHRAE, but it's IECC is used by Passive House Institute. Is everyone familiar with Passive House, or just the general basics? Taking some classes on it. Also, LEED. So USGBC LEED uses the IECC code. And the IECC divides the U.S. into 8 different climate zones. We'll talk about that in a second. Passive House Institute recommends using U factors in solar heating. So the question I get when I'm at a high-performance building show is, how low is your U value and how high is your solar heating? Because they want to basically reduce the amount of heat that's coming in at one point, and then during the winter they want a high solar heating to reduce heating. Talks about holistic building performances, not windows alone. So the reason I like Passive House is it talks about a whole house. What we end up getting into a lot of conversations about is just the window, right? And the bigger question is what part of the total wall? That's why I like these displays. So you can put a dual pane window, which is low E, which is not typically called a standard window, into a wall that's designed like this to get high performance. EnergyStar is a federal program. It's based on the EPA U-factor prescriptions, and it's based on 4 climate zones. And EnergyStar kind of started in the early 90s, and it depends on who you talk to, but essentially, Passive House is kind of like up here from a performance level. EnergyStar is kind of, it would be considered okay. EnergyStar was kind of put in place to go from like single glazing windows into like dual glazing with low E, which was a huge jump. Passive House is at a whole nother level from a performance standpoint. And there's a lot of changes going on with EnergyStar that we're still kind of waiting to hear about. Let's put that lightly. So here's the IECC climate zone map, and this is what Passive House will use. The reason I think this is interesting is take a look at sort of our region, and you can kind of see New England. It divides kind of the Mass and Vermont border in southern New Hampshire borders into 2 different climate zones. So this is what Passive House will use. So a house, I cover all of New England. I'm right here in Hatfield, Mass. I go up to Burlington, Vermont. It's a totally different standard versus the one that's in my own backyard. So that's a little bit different, but you can kind of see this is a little bit more realistic. When you look at the EnergyStar, it's just kind of a north central, south central, and southern. It's just a little bit more simplistic. There's not as much detail in with the EnergyStar program. And I'm not knocking EnergyStar, I'm just saying that's just kind of level 1. When you really get into like high performance, you're stepping well above EnergyStar. EnergyStar is sort of a baseline. Passive House is kind of that next level. Does anyone have any questions on this? And I think the big thing is to tie it all together is talking about the performance of a window and how you're putting this whole building together to meet these different codes. So this is always an interesting part when we talk about windows and doors. So a lot of pressure goes on windows and doors talking about performance and how well something's going to perform. But this shows the average percentage of heat loss in the winter out of a home. So 25 to 35% out of the ceiling, 10 to 20% out of the floor, You have air leakage, just in general, 15 to 25%, 15 to 25% out of the walls and 10 to 20% out of the windows. So when we're doing taking a holistic look and approach to, say, a high performance building, oftentimes we get into a conversation about, okay, is it a 0.30 U factor? Is it a 0.28? Is it a 0.27? We have these conversations when the easiest way to offset it is you could put a little bit more insulation in the attic, right? You can perform or use different sealants when you're putting together floor joists. You can seal and reduce air leakage. You can add another layer of insulation in the walls, or use a different type of insulation that has better R ratings. So typically, if you're you're using a check mark system, you're just looking at the windows like it has to be a 0.28 or I can't use it, right? There's a lot of ways to offset in a holistic kind of big picture look at a building. And this is one of the things we do. So windows is 10 to 20% of heat loss in the winter. So what we're looking at here is just a cross section. I passed that around, so it's basically what you're looking at is the corner section that you're looking at here. This is just the piece of glass, 2 panes of glass. All right, so essentially, what you're looking at is at 0 degrees Fahrenheit outside. This first one here is clear glass, and it's technically showing BTUs per square foot per hour. Is everyone familiar with what a BTU is? British thermal unit, right? So basically it's showing heat transference on a clear piece of glass. This is a piece of glass that does not have any coating on it whatsoever. There's no low E. Granted, 2 panes of glass is much better than 1, so you're getting much better performance, but there's still a lot of BTUs that are flowing through. What you can see here right off the bat is when you look at a low E coating on a dual pane, and then a low E coating on the tri-pane, drastic reduction in the amount of heat that's transferring, that amount of radiant heat that's transferring through. So we can see it goes from 21 BTUs to 1 on dual and tri-pane. Is everyone following here? Okay. Then the conduction of heat loss through the materials. So 13 BTU goes to 16 with low E, and then tri-pane is 10. Okay, and then the inside glass temperature, and this is an interesting one. If you walk up in the middle of the winter and touch a window and it's freezing cold, that means it's a low performance product, right? Typically like a single pane of glass. The better performance product, the one that have better coatings and maybe more panes of glass, when you walk up and you put your hand on it in the middle of winter, on a tri-pane triple glazing, it'll feel about 60 degrees on a 0 degree day. So that's performance. That's how well some of these products can perform. Is it does not feel, you don't feel the heat cold like you would on a traditional window. So the total BTUs exiting through the glazing would be 34 on a clear pane glass with no coatings, no argon, nothing. 17, right, on a dual, and then 11 BTUs per square foot per hour on a tri-pane. So you can kind of see the steps in performance. So let's take a look at the summer. So typically, percentage of heat gains in the summertime, 25 to 35% in the ceiling, 5 to 15% of air leakage. So heat coming into the home, 15 to 25% in the walls, and then windows is 25 to 35%. So during the summer, just due to the heat, position of the sun, you're getting a lot of heat gains in the summertime through the windows. That's why it's even more important. So looking at the same type of document here, this is summertime sun, 89 degree day. What's different between the sun in the winter and the sun in the summertime? Location. So in the summertime, where's the sun? It's higher, right? So when it's coming down at an angle. Okay? In the winter, right, you'll notice you got a lot more glare. It's because the sun's lower, right? So the sun it's not producing as much heat. It's tougher to reflect, but it's also further away, so it's not as hot. So summertime sun is higher, okay? And when you get into passive, you'll learn a little bit more about shading, okay? But what low E does, because the sun is coming down at a different angle, what low E does is it's a reflective barrier, okay? When you look at these windows, you would never notice it, but there's basically a coating on here that includes silver. And what that silver does is it reflects. So this is the exterior here, right? So the sun comes in at a high angle to here, and what the glass does, even though you can see right through it, the glass reflects and kicks light out. And it's all because of just the low E coating. That's the difference maker. So you can see here a clear dual pane, BTUs per hour, 179. You go just to a low E dual pane, goes to 63 BTUs, and then tri-pane goes to 57. So as you can see, the BTU via solar radiation reduction, 22%, and then it jumps to 73 to 75%. I mean, that's pretty significant. That's all because of just coatings on the glass. And that's the difference maker. So as you can see, conduction, heat entering, 7, 3 to 2 BTU, and then convection is also reduced. And then your inside glass temperature will be a lot less on the inside of the home. 90 degrees on a dual pane and then 82 degrees on dual and tri. So does that make sense? The impact of a coating on a piece of glass and the amount of glass? I just want to make sure, because it's kind of a fundamental part of the whole piece here. So you guys good with that element? Any questions?
How about locating the coating?
Locating?
Yeah. On
Which surface? Yeah. Great question. That's my next part. Steal my thunder a little.
Okay.
No, it's good. It's a great question. So we'll talk a little bit about which pane of glass you put the coating on and how that can change. Question.
So I saw that the difference between the double glazed and triple glazed aren't as significant as the single glazed and double glazed. At what point would it be beneficial to use the triple glazed? I'm sure they're more expensive
Yeah.
in terms of installation and usage on the building.
So it's a good question. We get that a lot. I think your biggest jump is, I think it's intent in what you're trying to build. We have some folks that they will only use a tri-pane or triple glazing just because that's the optimal. I've also talked to high performance builders that all day long will use integrity, dual pane, low E, and then they just sink all the rest of the money into other parts of the house to make it more high performance. So it varies. I think it depends on which path you're on. You know, in order to get a true net zero off the grid using solar, you would probably need to use some type of a tri-pane. But if you want like a really, really good high performance home, you can still use a dual pane with the right type of glazing and get away with it. So it's a good question. It's one we get because you don't see that jump to the same level, and typically there's a cost trade-off. So the other element of glass is protection from sunlight and fading. Now, this is not something I thought a lot about when I was your age, but when you buy a home, and you get into a house, and say you buy that brand new couch, or you buy that new rug, or maybe there's a piece of artwork or a photo or a painting. What happens is the sun comes into a home, and it completely just fades. Has anyone ever seen when you lift up a rug and then the floor, there's just a mark where it's just the floor is just completely faded, right? What that means is all of this UV light and some of the visible light is passing through the window into a living space, and it's beginning to kind of break down what's there. It's breaking down carpet, it's breaking down. You can break down paint. You can break down all these different things, which kind of affect the inside of the home. So the infrared, the heat, is typically harmless for fading, but that visible light in UV can do a lot of damage inside a home. I'll tell a story. So basically, we did a project at the Norman Rockwell Museum up in Lenox, Mass. Everyone know Norman Rockwell? Okay, so basically I go in, I'm the guy, the project manager going in, and I'm with an architect, and we walk into this rotunda, and basically it's 5 of the most famous Norman Rockwell paintings, like his masterpieces. And you walk in, and you're like, wow, this is great. It's kind of neat. And then basically they're like, there's 6 windows up above, and they're like, we want to replace these. And we don't want any light to come in, we don't want any UV rays to come in. And so part of me is like, oh, cool, what a cool project. And then I'm driving home, and I'm like, oh man, like I'm responsible to select the most optimal window to reduce the amount of UV rays to protect what are considered some of the finest Norman Rockwell masterpieces. I mean, it's a lot of pressure. So I naturally called one of my tech gurus inside the company and said, I need some help here. But those are the types of projects we sort of get into. And you don't think about it a lot, but we do it a lot like private residence. We've done a lot of projects, private residence, let's say down in Greenwich, Connecticut, or somewhere up in Vermont, where they have what would be considered highly valuable works of art. And if you do something and it's a UV, let's say it's just clear glass or it's just a low E, that might not protect the paintings that they have in their home. And we've gotten phone calls after the fact saying, why is my precious work of art fading? And it's not necessarily like our direct influence on that, but we have to really ask the next question as to what is the intended use of the home and how much light is coming into it. Question.
Is the fading pretty immediate, or how long does it take?
It'll occur over time, but I can tell you, we just moved into a new house and we put down a rug, and we've been there 2 years, and we've immediately seen that it was another product, competitive product that I believe was clear glass, and it took about 2 years to really see the difference between like one portion of the rug that was kind of in the shade a little bit and the one that was getting a lot of the light. So it can happen pretty quickly. It will be over time, but depending on the project. But I just thought that was a good example of the situations that you sort of run into and the impact of light. So laminated glass benefits, there's actually a PVB interlayer, which is what the laminate is. I always screw this up. Does someone else want to tell me what PVB stands for? Get an A for the day? No. Polyvinyl.
We got 2/3 of me.
I have everything memorized here, but that's the one that always stumps me still. Polyvinyl butyrol, PVB. So it's a resin, and it's a film that basically goes in between. So laminated glass is usually a PVB layer. You can do it for a lot of different things. Laminate, it can affect sound. It can affect strength. We do things such as ballistic glass. Doesn't sound like it's super important, but courts, jails, post offices, police departments. When we start to do commercial work, we get a lot of those questions. We bid on a job. It was the commissioner of the National Football League. He wanted ballistic glass on his entire house. True story. So it's interesting. You get into these projects, and the glass and the glazing becomes a big part of it. So energy efficiency, glazing systems, defining emissivity, what are the different types of low E, and where and how low E is applied, and how do we optimize it. So emissivity is best explained. This is a radiant camera photo. Basically, if you look at a parking lot in the summer, heat's beating down on it, what happens to the pavement? It's hot, right? So it's basically emissivity of the material is the relative ability of its surface to emit energy by radiation. Okay? So it basically goes from 0 to 1. In general, the duller and blacker the material is, like the parking lot, the closer its emissivity is to 1. Which means the more reflective a material is, like a shiny object, the closer it is to 0. So basically what happens to a parking lot, it has high emissivity. It basically just retains all the heat. It's not reflecting light, it's just basically absorbing it, right? So what happens, and what we do with windows, essentially, is we put a coating which reflects the light. That's what low emissivity is. It doesn't retain it. It basically takes the light and reflects it. It's used a product called sputtered coating, which is a silver-based, and it's basically vacuum deposited onto the glass. It's very neutral, and you can see right through it. I mean, to me, that's the most amazing part of the technology, is you're getting high performance on a dual pane or a tri-pane, and you're not really seeing a ton of difference. Now, one of the things we do get is if you have a colonial home and it's a single pane of glass, right, and you put something like this in, you're going to see a reduction in visible light. Just, you're going from one pane to two, and then you're putting a coating on it. So you're going to see a little bit of a change, but for a new home that's being built, you're not going to see much of a difference. So here we go. Surface 1, 2, 3, and 4. So looking from the outside in, so this would be considered surface 1 here. This would be considered surface 2, the inside pane of the exterior piece of glass. Surface 3 is the inside pane of the inside, and then surface 4 is what we call the interior. So depending on performance, coatings can be put on all different surfaces, and that changes performance levels. On a tri-pane, you guessed it, surface 5 and surface 6. So basically there's 6 surfaces of glass where you can put a coating to change and alter performance. So if you put it onto surface 2, you're going to get the best overall performance. It's going to reduce the overall solar heat gain. So it's going to reduce the amount of heat that's brought in through the glass. It reduces summer inside glass temperature, so you're going to feel less heat. And it reduces thermal bridging in the winter. Thermal bridging means the ability for cold or heat just to transfer from outside to in, and vice versa. So most standard product, we use this particular product here is what's called like a low E 272. And what that means is low E applied to surface number 2 and has 72% visible light that passes through. So basically that is, if you look at a Marvin or an Integrity or any one of our competitors, each standard low E is low E2 on surface number 2. It's just kind of pound for pound, you know, best performance at a standard price. When you put on surface number 3 in a dual pane, it increases the level of solar heat gain. It increases, because of that, your glass temperature. But we use this on typically like passive house type products, because in passive house, what they typically want in the Northeast is more solar heat. So surface number 4, so this is a newer technology, and what we typically do due to condensation, we'll put it on an all fiberglass product because the interior is fiberglass and it's a little more resistant to condensation. But this is a newer low E coating that goes to, we call it room side low E, or ERX. So basically it goes on the room side, and what this has done is it's created in a dual pane product. It's created a similar performance level to that of a triple glazing. So it reflects the heat out, it lowers the U factor, it reduces solar heat gain, and it decreases glass temperature. But it also, by doing that, increases the risk of condensation. The other piece is, you know, we talked about long-term performance. Since it's exposed to the inside, you could probably go up if you're cleaning it over time. I think basically what will happen is it will kind of increase in performance, and you'll tend to get a little bit more condensation, but there's a risk of it. So the benefits are great. You can get basically the performance of triple glazing in a dual pane glass. You can also apply it on a tri-pane to even further increase your overall performance. So how are the question?
Do the low E coatings and the glazings have a lifespan?
Yeah, so we talked about this a little bit. You don't see a lot of dissipation or reduction long term. It depends on the product and how it's being used. I think typically the gases will reduce over time slowly, but typically that low E is on there. So you're not going to see any effect. You'll see a negligible effect over like a long duration of time. It usually is not noticeable. So, I mean, we have products that have now been out there with low E 20 years, and you're not seeing like a decrease in performance. Material, sometimes you'll begin to see things break down like frames or you know, hardware and things like weather strip on a window, but typically the glass is pretty consistent. So the coating is applied. This is some nifty animation that I didn't do, so kudos to whoever spent time putting this together. So a sealant layer, followed by an anti-reflective layer, followed by silver, followed by a barrier layer, and repeat. So there's 3 silver layers, and then there's a chemical protector. So here's the part that I think is interesting. So all of that is being layered onto this glass. And if you looked at this, you wouldn't notice it, right? So it's basically, they say it's 1/1000th of an inch, and it's barely noticeable. But that's the technology that's sort of going into it, and that's kind of what makes the process pretty interesting. When we do factory tours, we go to the glass plant, and we see how the glass is made, and we also go to the coatings plant, and we see the coating being applied. And it doesn't look like much, but the amount of performance it provides is fascinating. Spectrally specific coatings, and we talked about this a little bit. So as you begin to get into the design and construction of a home or a space, you really want to think about how you're positioning the home. Again, I use that example of the house facing south with a lot of glass. Okay, basically that thing became an oven because they weren't very specific as to how they were positioning it. They weren't factoring in the height of the sun in the summer and then also in the winter. And they didn't adjust any of the coatings or use any tintings. So it's one of the things that as you get more into the design and construction of a building, you can use low E and you can use different types of glass to basically change the performance of a home. So we do this a lot. We'll have the back of a house be a certain type. We might use tri-pane in a certain part of the house and dual pane in another. We might use glass or windows that have higher solar heat capacity in parts of a house that you want to be more of an energy creator. So all of these variations are things that we sort of think about. It's something that we add to the process. So you got to be sort of specific. And as you look towards the summer, you can see a different angle of the sun creates different options. So in the summer, we always ask, whatever happened to the overhang, right? So you're starting to see homes now come back with more overhangs. Traditionally, a lot of colonial architecture, that's why they had overhangs, to reduce the sun. I think now with HVAC, heating and cooling, air conditioning, what has happened is you see a lot of just flush buildings, right? And they're just absorbing sun. And they're just cranking the air conditioning. I mean, that's not a good situation from an energy consumption standpoint. So things like overhangs to create shading drastically reduce your heating and cooling needs. One thing we do see a lot of is just large expanses of window walls with shades pulled across them because the heat is too much. That's a byproduct of just kind of building a quick home and not thinking about these things. We talked a little bit about the U factor. It is a measurement of heat transfer through a material or assembly. U factor is an assembled window. So basically, it's not simply just the center of glass. So we use U factor to measure the entire window. And typically, you'll see very low U factors in glass, but typically what we want is you may have a low U factor on glass, but it's basically the entire unit that you want to be concerned with. We talked a little bit about solar heat gain. So the lower the solar heat gain, the less heat that's transmitted, and the greater shading capability. We talked about heat generation of the solar heat spectrum. So that infrared is predominantly where most of your heat is being generated. So your coatings on a piece of glass can really affect that. And that's one of the reasons why these coatings are so effective. So taking a look at solar heat gain coefficients, I think the biggest thing to look at here is your indoor glass temperature. And you can see here your solar heat gain, right? The different types of coatings that you use can create a wide variety of performance. I had mentioned that 272 is sort of the standard. So that's surface number 2, 72% light, visible light, which would provide a solar heat gain of 0.41. As you begin to put more coatings and using tri-pane, you see a lot of variation. So this is something, when you get into the design process, this is why knowing your window guy is important. You know, we have a purpose. We can help kind of navigate some of these questions. We talked a little bit about visible light transmittance, how much light is actually allowed into a home. Typically between 0.3 and 0.8. But as you can see, this is a lot of design that we're seeing right now. Temporary, lots of light. And it depends on which type of tinting that you use, how much light is being let in. For triple glazing, 180 lets in 70% light. So what happens again is sometimes you'll choose a certain type of coating or a certain type of glass, and it'll go into the opening, and the visible light will be not as high as they're looking for. So this is a level of detail in the specification of windows that's important. All right, how are we doing? Are we?
Getting about time.
Okay. So, in conclusion, when you look at the solar spectrum, this is very interesting because what you see here on the right-hand side are different levels of performance. And we referred to this, that we had the UV light, we had visible light, and then we had the infrared light. And depending on which type of flash you use, you can see that the amount of transmission based on what type of flash you're using. And what I think is interesting is when you look at the near infrared, which is the heat, okay, this is just two pieces of clear glass without any coatings at all. So you can kind of see here, you're letting in a lot of UV, okay, you're letting in a lot of visible light, and you're also letting in a lot of heat. So as you go down, and you can see the reduction in the thresholds incrementally, you go down to that last one right here. So what that is this is triple glazing with 3 coatings. You can see you're letting in very little UV. You know, it's a little bit more tinted, and then basically you're not letting in a lot of heat. So you can kind of see the top of the threshold is just traditional 2 panes of glass clear. You're letting in a lot of energy. You're letting in a lot of light, but you're also letting in a lot of UV. You're getting okay performance. But as you can see, the different layers that you use can really drastically reduce the performance of the product. And this kind of shows a lot of the same stuff. It's all related to just overall your thermal performance. Essentially, what we like being a part of is kind of the design and construction of a well-performing home. Windows are just simply one component of that. But as you can see by some of these wall systems that you have here, it's a critical component of the wall structure. Glass and glazing has really evolved and come along over the years. It's a very interesting topic, and it's something where there's a lot of information out there. So you can use me as a resource. We got a couple of great professors here that can help you out with it as well. But hopefully this gave you kind of an introductory look at sort of how glazings and glass kind of affect the entire building envelope. So thank you guys very much. Appreciate it. Nice. This is great. Thank you very much.